Hello and welcome to Reill's tutorial. Today's topic will be about kinematics, and we'll be dealing with the last subtopic on kinematics called projectile motion. Please like, share, comment, and subscribe to the YouTube channel. Okay, come with me, let's dive in. When we talk about projectile motion, let's visualize a ball being kicked from the ground on the field. When a ball is being kicked high, the ball travels high and drops down in this pattern of the pictures that we have. The ball travels high this way and drops down. And this ball travels on the surface of the earth. So when we say something is being projectile, it's traveling across the surface of the earth. When an object that travels across the surface of the earth is called a projectile motion. An object that moves near the surface of the earth will not follow a straight line path. A straight line path is when an object travels up, down, left, and right. When an object moves across the surface of the earth like a ball, when you kick a ball up and travels down, then we refer to as projectile. If we launch an object at an angle other than a straight upwards, the object will be traveling along the parabolic trajectory. So here, this is an angle where an object is launched here, and the object travels near the surface of the earth. This way, it travels in this form. It's not going on a straight line, it travels in this form. So this trajectory is called a parabolic trajectory. Here is the the startup of the object when it was initially kicked up. Then it travels here on the x-axis. This is the x-axis. Here is the y-axis. It travels it travels up here, then goes as high. This is the highest point on the y-axis, whereby the velocity at y is equals to 0. Then returns back down here because it's reducing speed. Then it becomes a negative value, and this is the angle of travel. So this travel distance is called a parabolic trajectory. To simplify the analysis of parabolic motion, we analyze the horizontal and the vertical motion separately. But this is horizontal and this is the vertical motion. So for us to analyze this separately, we use the big five. And this is the best way to solve parabolic issues. So using this big five, like I mentioned earlier, we analyze this horizontal and vertical motion separately. So for the horizontal, a change in x, a change in the distance here, a change in x will be VOXT. That is velocity times time. That is a change in distance. And this is going to be in meters. You need to change in distance. However, for the heights, we have the initial height. But for us to get the height, it will be the initial height here. It is the initial height. The initial velocity times the height. The initial velocity times the height times time minus half gt square. G is gravity. T is the time. And the value that you get here will also be in meters. The y will also be in meters. So for us to get the velocity of x, should know that the velocity on the x-axis is equals to the initial velocity on the x-axis here. And for the velocity on the y-axis, and the unit of this would be meters per second. Meters per second. The same thing here. The velocity on the y-axis will be BOY minus GT. It's negative GT because of free fall. Remember we mentioned about free fall? So negative GT, because once the ball kicks up, it goes down against gravity. It goes down to gravity. So that's when free fall applies here too. So here will be meters per second. And for acceleration on the x-axis, the acceleration on the x-axis is always 0. However, on the y-axis, it's always negative g because it's going to go down against gravity. On the x-axis, there's not motion on gravity, but on the y-axis, it's free fall, so against gravity. So let's always remember, and that will be meters per second square. Okay, that is how we apply the projectile on the horizontal and the vertical line motion, horizontal and vertical motion. Okay, so now in analyzing this with angles, the quantity of VXO here, of VXO, is equals to VO. So once we have the VXO angle on the x-axis, it will be the initial velocity times cos theta, because of cos is on the x-axis here. That is the horizontal component. That's the horizontal component on the initial velocity of the initial velocity. Then for the y, VOY here will be equals to VO sine theta, because that is going to be the velocity component on the y axis, the vertical component on the initial velocity. So here is the y axis, and this here is the launch angle. So the ball is here, and the ball traveled from here to here and decelerated here. So this is the y, and this is the x angle of deceleration, and that's the travel distance, and that's how we calculate the angle. So since we have the angle here, from the distance traveled to the ground and the height, is how this has been gotten as this angle. And that's how we can calculate the projectile motion on the x and the y angle, on the x and the y axis. Let's dive in more some examples. Okay, looking at this example, an object is thrown horizontally with an initial speed of 10 meters per second. It hits the ground 4 seconds later. How far does it drop in 4 seconds? So this is an object here. Y here. Is thrown horizontally at a speed of 10 meters, VOX, at a speed of 10 meters per second, and it hits the ground later in 4 seconds. So how far did it travel in that 4 seconds? Because now I'm talking about the height travels down within 4 seconds. So we're going to look at the change in the height. Change in y is equals to initial velocity at y times the time minus half gt square. And we know that the initial velocity at y is 0 times the time 4 seconds is equal to 0 minus half g here is 10, then t is 4 square. So it will be half 10 times 16, and that will give us, by the time we multiply that will be negative 80 meters. The fact that the change is negative means that the fact that the change in y is negative means that the displacement is down. The object is being thrown down. Also notice that the information given about the VXO is irrelevant in this question. This information given about this V, initial velocity on the x-axis, is not relevant in this question. Okay? Now let's look at another question, a follow-up. So here it says, and from a height of 100 meters, a ball is thrown horizontally with an initial speed of 50 meters per second. How far does it travel in the first 2 seconds? How far does it travel in the first 2 seconds? So now, if you hear this, how far does it travel in the first 2 seconds, it immediately tells us that we should use the first of the horizontal motion question. That is, change in x is equals to VOXT, right? And that will give us our initial velocity at the x-axis on the horizontal is 15. That's 15 meters per second. Then the time travel is 2 seconds. By the time we multiply this, the change in x is equals to 30 meters. How far? That is how far does the speed distance, how far does the ball travel 30 meters? This is show that the ball doesn't, this show that initial velocity of 100 meters high above the ground is irrelevant. This is not relevant. The ball travels 30 meters in 2 seconds once when it was hit. So this is the answer we're looking at. How far does it travel? Okay, let's look at another example. An object is projected upwards with an angle. An object is projected upwards with an angle of 30 degrees. That is the launch angle, and an initial speed of 40 meters per second. How long will it take for the object to reach the top of the trajectory, and how high it is? So we're looking for the time, and we're looking for the displacement, distance. Okay. So when the object reaches the top of the trajectory, its horizontal vector is its velocity vector is horizontal. That is Vy is equals to 0. that is Vy is equals to 0. So when Vy is equals to 0, we can set it as equals to 0. So using it so that Vy is equals to 0, which implies that Voy minus gt is equals to 0. Okay? Then now for us to get the t, how far does it travel? We're looking for the t. Then we know that t here, t is equals to Voy over g. Okay? Voy over g. Then now let's put the values in. We know Voy is equals to Vo sine theta because of the angle on the y-axis and the x-axis is on the y-axis is sine. So sine 30 sine 30 all over the g is 10 over 10. So therefore, the value of t will be equals to, by the time we calculate sine, Vo is 40 meters. That's 40 sine 30 sine 30 all over 10. By the time you calculate this, that will give us 2 seconds. Okay? So therefore, the time taken is 2 seconds. It takes 2 seconds to travel. How long will it take an object to reach the trajectory? That is 2 seconds. Right. If it now we know that t is equals to 2 seconds. Then now the height. For us to find the how high does it travel, the change in y is equals to VOT minus half GT square. So that would be VOT is the velocity at the y-axis. So that would be VO sine theta bracket t minus half gt square, half gt square. So therefore, now let's put it values. V is 40, sine theta is 30 degrees. Then the time is 2 seconds minus half. G is 10 meters per second, gravity. Then T is 2 square. Then we multiply that, this will give us 40 times sine 30 times 2 minus half 10 and 2 square. We then calculate all of this to give us 20 meters. That's where the object will travel at 20 meters high. Let's say, how long will it take an object to reach the trajectory? Okay. All right, so this is the end of projectile motion, and this is the last subtopic in kinematics. Please like, share, comment if you have questions, and also comment if you need me to make some improvement in that, and subscribe to my YouTube channel. Thank you, and hope to see you in the next video.